Our next speaker is Stefan Baumgartner. He is a moderator at Eurorust, organizer of Rust Linz, so very active in the community. And he's also kind enough to be an MC tomorrow.
Yes.
Here on this.
Yes.
in this
Taking
track.
over your job.
Exactly. So he's coming for us. He also wrote some books on programming, mostly TypeScript. And I did have a question when I was reading through all his socials. He's using the nickname Dead Parrot.
Yeah.
And I was wondering, where does that come from?
So a couple of years ago, I was registering for two things in one April's night, which was I was registering for Twitter and for the last Monty Python shows ever to happen. So it comes from Monty Python, and I thought,
It's just resting.
It is based on a Monty Python sketch, and I thought, yeah, it's kind of fitting because the Twitter logo was a bird, so maybe use the same handle. Little did I know that this was the perfect foreshadowing, because we all know what happened to Twitter. So yeah, nothing more than a dead parrot right now. But, yeah.
All right.
Super nice.
That's a good story. Thank you so much, and
cool.
Please take it away.
All right, thank you very much. Okay. So, hello everyone. Thank you for coming to my talk. Thank you for this lovely introduction, which means that I don't need to introduce myself anymore. We can get directly to the meat. We are going to refactor some software together today. The basis is a simple key value store. It's a web application. You send some data via POST request and store it in some sort of database. And with a GET request to the same URL, you retrieve the data again. It uses Axiom under the hood, but don't worry, you need to understand any Axiom intricacies. You don't even need to understand web applications. We are focusing just on the Rust part here. The important thing is that in this scenario that we are having, we want to prepare our code base for future development. So product management is onto something like they always are, and we want our software to support their ideas. And this is why we want to refactor the existing code into something much, much more sustainable, because believe me, the code as it is right now is a mess. Very intentional, because it was just hastily written over the course of a weekend. And as always, all the examples in this session are fictional, but rooted in reality to save the innocent, which is, I guess, me. All right. So before we start, we need to look at the code base at hand. And you need to be strong now, because this is not for the faint of heart. This is our database, ish. So, or actually, database, I don't know. It's a simple hash map that stores a tuple of string and bytes based on a string key. And since it's a web application, the string in the value represents the content type we want to store. We are going to save that. And the bytes are the raw data. What's nice about this particular slide, and there's not a lot of nice things on it, is that we use a type alias to not always write arg, rwlog, whatever. We just have a name, a proper name for the things we care about. And this is the clicker. Okay, cool. And this is the main app. Those are two handlers that are mapped to the respective URL endpoints. In one handler, we handle the POST request that stores data along with its content type based on a specific key. In the other function, getKey, we process a GET request to the same URL, returning the stored data if available. If no data is available, we send a 404 status code along with the error message. There are a couple of highlights. First of all, we apparently don't care about error handling. We have a couple of expects and unwraps in our code, which is funny because we are returning a result already, so why not just, bubble everything up. The nice thing about those results is that if Axiom, the framework that we are using, gets one of those results, it will just convert it to either a success response or to an error response. And Axiom needs something in there that can be converted into an HTTP response. For that, they provide us with the into response trait. This intuitive response trait is already implemented for a multitude of basic types and also tuples of basic types. Like we see here in the getKey function, where we cobble together some basic data to, get it done. But yeah, this would be it. If it weren't for the idea of product management to find a new product direction, they want to pivot our app, which is a very basic key value store, into an image processing app. Okay, this is not right, I'm sorry. This is much, much better. Now we are professionals. Now we can continue with our work. All right. Sorry, the clicker is acting up, don't worry. Anyhow, we already do have a feature implemented that we want to expand upon. So this is another endpoint where we create a grayscale version of every image that is stored in our database. So you give it a specific key, it takes the key. If it's an image, it creates a grayscale version. For that, we read from the database. Again, notice the unwrap. If we get some content, we want to continue. Otherwise, we return with a not found error message in status code. If the content is an image, we create a dynamic image. This is a type provided by the image crate, which is an excellent library if you want to do something with images in Rust. It basically does all the heavy lifting for us. It has a really, really nice API, and you have a multitude of things that you can do with it. And if you're not dealing with an image, we are returning a forbidden status code because we can't make a grayscale version of data that isn't an image. Once the image is received, we create a new buffer vector where we store the modified values and use the dynamic images as API to produce a grayscale PNG, which will be stored into that byte vector and converted into a response. So a lot of stuff is happening in those couple of lines. So this is everything that is actually the meat of this function. But yeah, a lot of stuff is happening, but eventually, I think it's fine. The code does its job. It has been hastily written. It lacks proper error guidance, yeah. But if we don't need to touch it and we're still, in the prototyping phase, then we are good. However, we aren't, because this should be a product in the future. We need to revisit our code base continuously and add new features or fix bugs or whatever. So let's make our lives easier. And the first thing that bugs me is the atrocious error handling, or actually the lack thereof. We basically don't handle errors at all, except when we produce a few specific status codes. We ignore a lot of the errors that could really happen and panic using unwrap and expect. And we need to do lots of manual response building with custom error messages. And this is something that we want to streamline. We want to streamline this error handling, and we want to make good use of the built-in error capabilities of Rust. And we do so by implementing a custom error type. So you've probably done this in the past, most likely with a library like this error. But here I want to implement error handling by hand and step by step, because I guess we're onto something here. Our type is called key error, and I suck at naming things. So, except with my children, they have great names. But here I really, really suck at the naming things, so bear with me. It holds a status code, which is a type from Exum, like not found, forbidden, every HTTP status code that you can think of, and a string which represents the error message. And we implement a few functions on it. A constructor function that by convention creates a new structure. Note that I use impl into string, which allows me to add anything that can be converted to a string as a function parameter. I'm using into because the into prefix gives no indication of the conversion costs, whereas if I would use something like toString, for example, with toString, there's always a conversion cost attached to it. It's always an expensive operation. I'm also creating a few shortcuts, so I don't need to write every message over and over again, and this is everything our type has to offer. To make it an actual error, I need to implement the debug trait, which I can simply derive. I also need to implement the display trait, which I need to write by hand, but I just put out the error message. So now I can print the error on standard out and ignore it in the log file. And with those two traits, we finally we can implement the error trait. They are a prerequisite for implementing the error trait. And with that, it's now a proper Rust error like it should be. Next, we want to make it compatible with the errors that could actually happen. And for that, we implement the from trait for every error type that can occur. It's possible, for example, that the database is corrupted and we get the poison error. And we want to convert that into a Kiwi error. Same for the case if the image can't be loaded or modified or anything related to the image crate, actually. This should also be converted to a Kiwi error. And last but not least, we implement the trait from Axiom to convert this Kiwi error into a response, making every error case we have in our application compatible with the framework. All right, magic pixie dust time. Let's see where our refactoring has led us. So this was the main app, the get post handlers before our changes, and cool. And this is it afterwards. Not too big of a change, but we finally got rid of all the unwraps and expects and have proper error handling and error propagation. If something goes wrong, we just bubble it up with the question mark operator, and the error that we have will convert easily into an Axiom response without us needing to do anything. And in the get case, we also make use of the shortcut methods if we want to say that we haven't found something under that key, returning an error here. The grayscale method itself looked like this, and it also becomes a little cleaner. We bubble up the error case in case the database crashes or the image can't be loaded or modified. And the most important thing here is that we don't expose any details, but rather hide the complexity of the error message creation and status codes in our shortcut functions. So now we have a name, now we have something that is tangible, something that you can take to your colleague and they know what you are getting, or they know what they are getting. Ultimately, we created a type that can be used universally in case something goes wrong. And I did do that by hand because I think there's a little pattern hidden there. So the interesting thing about creating this custom error type is that we unknowingly follow the pattern that is so common in Rust that I struggle to find a proper name for it. Maybe the name is just software engineering, but I think it's a core pattern. We need to apply to make Rust code easier and make it more maintainable for future changes. First, we create a type, and this is the most important one because suddenly we have a thing instead of a process. We don't talk about what we do, but rather about what is involved. And then we implement standard traits to make it compatible with the built-in language features. Then we implement library traits to make our type compatible with the crates we use from the vast Rust ecosystem. It's type, trait, over and over again. Clicker. And let's see that in action with the next example. All right, this is the grayscale function as it looks right now, and I want to focus on this process where we create the grayscale image from our original image. And I said it already, a lot of stuff is going on there, lots of details happening. The problem is that in just a few lines of code, we expose much complexity that we even can't correctly name. We need to deal with vector buffers, cursors, content types. We load, we convert, we send a response, everything in those couple of lines. But you only know that because I told you. We see what's being done instead of what is involved. And if you wouldn't have written this on your own, or if I wouldn't have told you, I think it might be really, really hard to understand what's going on without any context at all. Let's change that again with type, trait. Let's apply this pattern and see where we get. I want to focus on the last line, on the sending of the response. I want to focus on how we create an HTTP response, and for that I create a new type called image response. And this image response stores the data I want to send. A tuple type is ideal for this purpose. It enables me to add my application's domain in form of this particular name on top of existing types. The constructor function takes an into bytes parameter, allowing me to convert any data that can be converted into bytes into an image response. Now I want to implement the standard traits. So I can convert the dynamic image I have from the image creation part earlier to an image response. I use the try from trait to indicate that this operation may be potentially problematic. Hello again, Kiwi error. Great that we did that. And in the conversion, I had all the details that are just there to create bytes out of a dynamic image. The vector buffer, the cursor, the conversion to a PNG, and since I use KV error, I can propagate the error in the writing process. I do this for a reference to dynamic image and also for the own type, allowing me to convert it for many situations. So implementing standard traits, done. And the nice thing about this is that while it's still the same code as in the function before, we now know from its surroundings what it's all about. We want to create the response from an image, and that's the steps we have to do. It becomes clear by just looking at the function signature instead of going into the nitty-gritty details. So, and then we want to convert the image response into an actual exome response. So we implement into response for image response, setting the content type and the response body, and then call into response again. So this is exome framework code, but it's very, very handy. And again, we hide lots of the complexity in there. We don't need to focus on having what's effectively an array of header information, an array of tuples of header information, and then the bytes, and then calling into response. The only thing that we care about here is that we want to create or want to convert an image response, our own type, to something that Axum can understand. Implementing library traits, done. Again, pixie dust time. Let's see the magic happen. This has been our original. And no, it's just 5-6 lines of code, but there's lots of details in there, lots of implicit knowledge. And instead of writing this, we can just simply do this. We have the image, we call the grayscale method on it, and then we create an image response out of it. And since the interface from image response try from is the same as in our grayscale function, it returns a result of either bytes or a KV error. We don't need to wrap anything in an OK or error or anything. We just can return image response try from image. And even better, since image.grayscale also returns a dynamic image, I can put it in one line. A simple single line that almost reads like English, Try to create an image response from an image that is converted to grayscale. I think this is very, very elegant if you compare it to what we had before. But not only is it elegant, I think we have achieved something very important. And this was my aha moment. So when I did that originally, this is where I figured out, wait a second, it's important for us that we talk about what is involved rather about what is happening. This makes it clear why we do certain things to begin with. And Rust types of system supports you really, really well. You start thinking about what is connected and how it is connected. And I think personally, so this is now a little bit philosophical, but I think this was always the true promise of object-oriented programming. You have stuff that can talk to each other, and by the interfaces or by the contracts, you define how they should talk to each other. And yeah, and it's also nice to collapse everything into just one line and be done with it. Okay, next one, the last one. I'm still not too happy with how we deal the type that we store in our database. So this is this part. We want to look at how we retrieve the data that we work with. And this piece primarily involves wrangling with different data. We perform all the necessary steps to ensure that in the end we are working with an image that we can convert into a dynamic image so that we can do the actual work at hand. And the problem here is that we handle the kind of data too late. So we want to pivot to an image processing software. So images should be the main focus of our app. Instead, we still work on tuples to figure out which part defines what. And we have lots of if-else branches that take up a lot of space for something very, very simple, like, well, is the key here and is it an image? So let's try it again, almost with like a mantra. Let's try the same process again. Type, trait, trait. We want to be explicit about what we store. We care about images first and foremost, so having an enum with 2 different variants is actually what we're looking for. An image that stores the type dynamic image and everything else, so this is perfect. This will do the trick. And if you want to be explicit about more things in the future, adding another enum variant is actually quite easy. When we create a stored item, based on the content type, we can already create the dynamic image that we want to store. Yes, this changes the semantics of the data that we store a little bit, but again, this is in purpose of the app that we want to support. At creation, we decide how we want to handle the data. We define the purpose of the data, and it's not an afterthought every time we want to work with the data. And we also get a central place to modify and change things. After the type, we implement traits, and this time we don't need any standard traits, at least for now, but we can implement the library trait to make the stored type work with Exum. So here, we want to be able to return any stored type via an Exum handler. If it's an image where we don't do any modification, just create another image response. Otherwise, do the same thing that we did earlier, where we cobble together the content type, add the data, and call into response. So, how has our code changed now? It's actually a small change, but it has a big impact. This has been our original database, which is now working on a stored type. And this is, in my opinion, a huge improvement, because instead of having a tuple of things that can be anything, we know now what we want to store. If we look into it, we get more information on the variants. So we have a term, a noun, something to hold on and to communicate. This is the original storing and retrieving. Again, we also changed to a stored type, which, thanks to the into-response trait and proper error handling with Kiwi error, great that we did that, also becomes a lot simpler and clearer. So I like now that in the post-Kiwi, that we actually create a new data type and take care about where we want to store it later on. And again, error propagation through the question mark operator. It's happy path programming in Rust is fantastic. If doing it right, you don't need to handle any error ever at all. You just need to bubble it up. And even nicer is that in the getKiwi part, we just extract the element and send it back. Fantastic. Otherwise, we send an error not found. But the biggest change happens in the grayscale function, which is now in this state after the last refactor. So instead of this, we just reduce it to its most minimal version. We read from the database, we get the data, and if it's an image, let's do stuff. So we went from a large piece of code with numerous details to something readable and understandable. It utilizes terminology that aligns with our applications domain. If I give this piece of code to you, you're going to figure it out. You're going to figure out what's happening there, even if you don't have any context. All right, on to the finale. So I guess I'm very much within the time limit. All right. Again, why did we do that? We want to pivot. We want to have a code base that is maintainable, that has a certain longevity, where we can easily add new features. And if we find bugs, we know exactly where we want to handle them. So we had some smaller changes, we had some big changes, and it's time for our new product to shine. We want to go forward and implement new features. This was the original grayscale function from the beginning. This is how it looks right now. So this is a huge, huge difference. It's much easier to understand. It's much clearer. The hard parts are somewhere else. The right abstractions can be modified and changed without needing too much, needing to touch every piece of our handler functions. This makes it great for adding new features. So let's implement a thumbnail function. Boom. There you go. Now we want to get brighter versions of an image. Boom, here again, look at that. So I'm basically just changing one meta call. That's all I do. It's the same piece over and over again. We just changed a single line. And basically everything that the image crate has to offer now can become a feature. And we are fast because we move the details into the right abstractions. We don't accidentally introduce copy and paste errors because everything that is process and ceremony is someplace else. Everything that happens in these functions is clear and unambiguous. there's some message in there. First of all, one thing that I really, really like is that we see all previous refactorings fall nicely into place. It was really, really good that we started with the error handling because errors can happen, and Rust is a great language to avoid errors. So if you know which errors can happen in your software and you have the right types for it, this makes a lot of things for future refactorings much, much easier. With proper error propagation, we actually don't need to do a lot of error handling. We just call the question mark operator. It's also great that we started to store the dynamic image to begin with, and not just some bytes that we get, but we do the conversion before we actually work on the data. With that, the dynamic image being such an important piece of our code, all the other conversions align nicely because they already work on dynamic image. Some more sensible refactorings, like preserving content type for images, etc., happen on a type level and not on a handler level. And we introduced vocabulary that we can easily grasp, and we know what's going on. And this makes adding new features really, really easy. But I want to stress the fact that we didn't do that to just create the most elegant code base of all time. There are so many people out there who can be really, really dogmatic about polishing every little bits and piece of the code. This is a side effect. Having an elegant code base is a side effect of a much, much more important fact, namely that we do that to increase efficiency. Efficiency either by developing new features, but not alone, but also debugging existing features. Because understanding where problems happen. Because suddenly what belongs together is together. And with that, we can easily figure out if something goes wrong, where it is. And we notice one place where we need to touch it. And with that, to me, Rust's type system supports or even fulfills the original promise of object-oriented programming. With different parts of your application that hold data can be glued together by defining the right contracts. And don't forget that code is communication. You want to write something that is understandable not for you, but for others as well. You rarely work alone. You rarely work on your own. And if you do, you always work with future you. So future you needs to pick up the stuff that you've written before. Be nice to future you. So make pragmatic decisions over dogma. Do the right refactorings because it helps you in the future and you communicate with others. A single refactoring technique, introducing a type, implementing standard traits, implementing library traits, type, trait, is all you need to do to get the best out of your Rust code. Thank you very much.
Thank you so much. Thank you so much. Lots of good advice in there.
Yeah. Do I have 1 more minute?
Yeah.
Cool. Because we are in a cinema, I do some Avengers-style post-credit scene. All right. So, do you remember how I was annoyed about the database? That it isn't actually a database? Well, I make it a database by writing a database trait and implementing it on my shared state. Now it is a database by name. And I'm really good at naming things. So, and with that, putting all that stuff of getting an image or not getting an image into this trait with this getImage function, the grayscale function just becomes a one-liner. Image response derived from the image that I want to get from my current state. So now I'm having a database. It's database and something like that. But more importantly, if I now convert to an actual database, the code base doesn't change that much. I just implement the same trait for a different type. There you go. Thank you very much. Sorry, this was very important to me.
That's perfect.
No, that was great. That was great.
Questions.
I think you're the first one I've seen today who's used like slide transitions to great effect, or at all actually. Yeah.
Still waiting for a 3D presentation.
Yeah. All right, let's see where the first question is. Is the catch box already on its way?
Yeah. Ario's completely ready.
I see all the way up there is one.
Yes, this is going to be the throw of the year.
Just it can go in multiple hops. It's fine. It doesn't need to go in one way.
Ooh. See? And this is how BGP works. Sorry. DNS and BGP is my life.
Yeah, when you hear hops, you just immediately go, oh, BGP, yeah. All right. What's your question?
Yeah, so I've only been doing Rust for a little bit, so my question is probably pretty newbie, but when I first started doing errors, I was doing a struct, and then I started reading blog posts that recommended doing enums. So now in your presentation, the error is a struct. So now I'm left wondering, are there different situations where I'm supposed to be using structs versus enums for errors?
So I guess the most honest answer to that is, use whatever you think is right. The great thing about using an enum is that usually you have lots of different errors from different parts of your application, like libraries, third-party libraries, or your own, that produce a certain type of error, and you want to convert that into your own error. So an enum is really, really great because you want to distinguish between those variants. And this is what an enum is for. So having the variant A from this crate, the variant B from this crate, whatever. In my case, this was rather special because in the end, I'm going to have an HTTP response. So I actually didn't care too much about what the actual error was, but rather about which status code to send. So every conversion that I did was not trying to figure out which variant it was, but sending the right message, which is in the conversion from poison error to whatever. I did an internal server error with a proper error message. And this was the data that I'm concerned about. So from that point onwards, Exum takes care, and Exum doesn't care if I have an enum with variants, because all it does is creating an HTTP response. So yeah, so the reality is it depends. Cool. Oh, I wanted to say that the entire time. It depends, that's like software engineering is, but it's true. Whatever works best in that case. I also used a struct with a tuple struct, and this is just because I like it more. But you can use a struct with property names and whatnot. So totally up to you.
Nice. Any other questions?
I see one over there, and the catch box is on its way.
Where do you go to see that? I
see
just
it.
see
Packets
like
dropped.
Yeah.
Tomorrow I'm going to bring my sunglasses.
There we
Right?
go.
We need to put a line on it.
Yeah.
Thanks for
yeah.
great talk. Yeah. I'm wondering about the tight coupling side.
About what?
I'm here.
Yeah.
I saw you wrap the key value error with HTTP status code.
Yeah.
Imagine we are not using REST API,
Yeah.
but we want to separate our storage layer or whatever business logic from the API layer. In the future, I want to use a message broker to integrate with my components. So it looks like tightly coupled with logical things with HTTP things.
Yeah,
What do you think
absolutely.
about it?
This is an absolutely valid point, but this is the beautiful thing about refactoring. You don't stop there. If in the future you want to talk to a message broker or whatever, I guess it makes sense to do it like the other person said, to have an enum that is agnostic to his response format, and then decide on the status code by implementing the inter-response trait for this particular enum and looking at the variants and do the decision there. This is totally fine, because then you have a type that you can use everywhere for all message protocols that you want to use. But the interesting thing about this is, I'm not doing any premature optimization here or anything that makes it the most elegant version that it can be, so it works in the most scenarios that it can be. I'm doing it for what's coming up next. And I'm very well prepared for what's coming up next. If we decide to support more protocols, more outputs, whatever, then this would be the next step. So absolutely.
All right. Where's the box? Where are the hands? Excellent.
So you mentioned already during your talk that naming things is hard.
Yeah.
And combined with that, I sometimes come across projects where they implement their own logger trait or type, for example.
Logger, yeah?
Yeah, which is one of those things that everybody uses, logging and tracing.
Yeah.
So you shouldn't create your own type for that, right? Because otherwise you're just implementing all of these interfaces all the time. So how do you make the decision between doing that first step, introducing a type,
you are hitting a
leaving
nerve
that
here.
to a library.
You are hitting a total nerve here. I mean, I'm biased here because I work at Dynatrace, which is a monitoring and observability company. And when we do Rust, we do a lot of Rust in our company, and we use the OpenTelemetry crate and just be done with it. And we are very, very happy with it because it totally lines up with the software that we use. And for us, it was an easy decision. We want not only to log something and browse for logs and ignore it, but we want to send it to our monitoring software, and there's an ecosystem for that, and it's actually pretty good. So our decision was, let's take what the ecosystem offers for us, because we don't want to do their work, We want to move along with them. And if we don't want to do the work, Dynatrace is contributing to those crates, but you know what I mean. So this is something that should evolve separately from us. And it's good that it can evolve separately from us. So this is a dependency that we willingly take to have our software monitored. And yeah. So the decision is rather, I guess you need to evaluate it based on your context. If you work in an environment where every piece of your software needs to be certified and run through a certain piece of process, maybe having a third-party dependency that has lots of subcrates is not the right thing. Maybe you want to do it on your own so you know what's happening there. But in our case, it was easy. It was, hey, we want to have it in Dynatrace. This is the way to do it in Dynatrace.
Thank you.
Yeah.
Cheers.
Cool company.
Yeah, we can do one more question.
Yeah, if you want, we can do more. We've got some time.
I'm here all day.
Yeah, and I see a raised hand, so we could make this work. All the way in the middle, of course, so we could just lots of throwing really far.
Let's hop this again.
No, it's going to be a personal delivery.
As long as it goes up. This is a good team building exercise.
Thanks.
This is great.
Hi, thanks for a great talk. I really enjoyed it.
Thank you.
I noticed that you used a bunch of good things from Rust, so traits, structs, enums. I noticed also a very glaring lack of things like generics.
Yeah.
Now, was that on purpose?
Yes, this was on purpose for this kind of talk and for. It came along actually with the framework that I was using, which builds heavily on generics, so it does the heavy generic lifting for us, but there would be an extension. So this talk is based on a workshop that I did, and one of the steps after that was introducing a trait and working with generics to swap out the databases from, my hash map key value store to actually talking to a Postgres database or to an object store or whatever. And this is where we would have to introduce generics, but it's, 30-minute time slot. But really good question. So generics would be the next step, and they align very, very well with traits. So actually the last slide that you saw was kind of a, next time on refactoring in Rust. Because there we are not introducing a type, but we're introducing a trait. So we turn it around. We're introducing a trait and implement it for existing types. And this is where the generic stuff starts and where we basically create our own library for that. Yeah.
Come back for Rust Week 2026.
Oh, please. I'd love to. It's a fantastic conference.
We'll talk about generics.
Yeah, exactly.
Yeah, that's it, right?